Okay, let's take a look at section 7.6, complex numbers. We're going to start, we've talked a little bit about this, start by looking at the equation x squared equals negative 4. X squared equals negative 4 has no real number solution. However, it has two solutions in the complex number system. Complex numbers are based on the symbol the square root of negative 1. The symbol has no meaning in the real number system, but in the set of complex numbers, this symbol is given the following definition. And really, you just have to memorize this definition and keep in mind that it repeats. So in the imaginary number system, when we look at I is equal to the square root of negative 1. I squared is equal to negative 1. I to the third is negative the square root of negative 1, or negative I, and I to the fourth is 1. So when we look at these values of I, you have to just ask yourself, how many times does 4 or 6, how many times does 4 go into 6 and what's the remainder? Because this will repeat so that I to the fifth is the same as I to the sixth is the same as I squared, I to the seventh is the same as I to the third, I to the eighth is the same as I to the fourth. And it continues on. I to the ninth is the same as I to the 10th is the same as I squared, I to the 11th is the same as I to the third, and I to the 12th is the same as I to the fourth. So you see it's a cycle every 4 repeat. So when you look at this, I to the 6th actually becomes I to the 4th times I squared. I to the 4th is 1, I squared is equal to negative 1. So the answer to that, I to the 6th, is negative 1. When you look at negative 7, that's I to the 4th times I to the third. I to the 4th is 1. I to the third is negative the square root of negative 1. So you get negative the square root of negative 1. I to the 15th becomes I to the 4th times I to the 4th times I to the 4th times I to the third. So that just becomes 1 times 1 times 1 times then negative the square root of negative 1. So the answer is negative the square root of negative 1. And that's how you can think about that definition of an imaginary number. In the complex number system, the set of complex numbers is the set of all numbers that are of the form a plus bi, where a and b are real numbers, but a is considered the real part of the imaginary number, and bi is considered the imaginary part. Where a and b are real numbers and I equals the square root of negative 1. So a plus bi, a is called the real part, and b is called the imaginary part. Equality of complex numbers. So here, if I have a plus bi equals c plus di, then what I know is that the real parts are equal. A is equal to c, and the imaginary parts are equal. bi is equal to di. If you look at these examples, I have two complex numbers equal to each other, so 3 plus 5yi is equal to 6x plus 15i. To solve this, set the real parts equal to each other. So 3 is equal to 6x, so x is equal to 1/2. Then the imaginary parts. 15yi is equal to 15i. Divide both sides by 15i. and you will get that y is equal to 1. Oh, I changed that. I'm sorry. I looked at my answer key. That's a 5, and that's a 5. So therefore, that is equal to 3. Second one, again, 27x is equal to 54. So x is equal to 2. Then 3yi is equal to 36i. Divide by 3i. So y is equal to 12. So you're just taking the real parts, setting those equal to each other. Those are the real parts. And then the imaginary parts, setting those equal to each other. Now in adding and subtracting complex numbers, to find the sum or difference, you simply add the real parts together and you add the imaginary parts together. So when we look at this example, 2 plus 3i plus 6 plus I, we have the 2 plus 6, that's the real part, plus then 3i plus I. So in adding these together, I get 8 plus 4i. The second one, 3 minus 1, and then plus 5i minus 2i. That should give me 2 plus 3i. Multiplying complex numbers. Now you just FOIL like you would any other pair of binomials. So you're going to FOIL. Here you would have a times c, gives you ac. Then a times di, which is going to give you that ad. Then bic, which will give you that bc times I. And then bi times di, which is going to give you bd. So let's take a look at what happens when we use the distributive property on some complex numbers. So 2i times 1, simply 2i. 2i times I becomes 2i squared. But remember, I squared is equal to -1. So this becomes 2i minus 2. Number 2, we're going to FOIL. 2 times 4, that gives me 8. Then I get plus 10i, then plus 12i, then plus 15i squared. Combine like terms and recognize I squared gives me a -1. That turns that into -15. So I have a -7 plus 22i. Look at number 3. When you FOIL number 3, what's going to happen? Difference of squares, those middle terms are going to cancel. So you have 9, and remember I squared is a -1, so that becomes plus 1. So now you have ended up with just a real number. Last one, 2i. So remember this one, you're going to get 4i squared, so then you're going to have -4. We've seen conjugates before in the last section. Now the conjugate is just the opposite sign of the complex number. So if I have a plus bi, then the conjugate is a minus bi. And their product becomes a squared b squared, as we've seen before with radicals. So now, find the product of the given number and its conjugate. So if 2 plus I is the number, then 2 minus 3i is its conjugate. So now you can FOIL this if you want, or you can go back to this rule that says I'm going to have a squared and then it's going to become plus b squared. So that's going to give me 4 plus 9. Now let's actually take a look at that and break that down and FOIL it. So I have 4 minus 6i plus 6i minus 9i squared. That's always going to happen. You're always going to have minus a constant or a coefficient and then squared. That squared, I squared, is -1. That will always make this a positive. So you have a squared plus b squared, which in this case is 13. For the second one, 5 plus 4i. Again, those middle terms will cancel. So you will have a squared, which would be 25, then plus b squared, which will be 16, which should give you 41. Division of complex numbers, and again, you need to look at these and think about multiplying by the conjugate, because it's like having a radical in the denominator. No radicals in your denominator, so you're going to multiply numerator and denominator by the conjugate. So in this case, 3 plus 4i, 3 plus 4i. Distribute property on the top, so I get 15 plus 20i. And then the conjugate rule on the bottom is going to give me 9 plus 16. So I have 15 plus 20i over 25. Now here, go ahead and factor out a 5. That's going to give you 3 plus 4i over 5 times 5. They cancel. You are left with 3 plus 4i over 5. Again, multiplying by the conjugate, 2 minus I, 2 minus I. Numerator, I will have 6 minus 3i minus 2i plus I squared. In the denominator, I will have 2 plus 1. So this gives me 6 minus 5i minus 1 over 3. And so I should have 5 minus 5i over 3. Number 3, the only thing in the denominator is I, so I'm simply going to multiply numerator and denominator by I. That gives me 3i plus 2i squared all over I squared. So I'll have 3i, and that will be then minus 2 over minus 1. So that will become 2 minus 3i. For that example. Okay, looking at the square root of a negative number, for any positive real number b, remember the square root of negative b becomes I square root of b. And with any of the operations you do with a negative number under the radical, please handle the imaginary number first. Otherwise, you're going to have the wrong sign on your answer. So when you look at number 1, the first thing you should do is rewrite that as the square root of minus 1, square root of 9. So that will become 3i. Number 2, so you have the square root of minus 1, the square root of 36, square root of 2. So that becomes minus 6 square root of 2. Minus 6i. Okay, imaginary solutions to equations. So when you are solving an equation, now in the complex number system, you can have an imaginary solution. So here I have x squared equals 9. So now when I take the square root of both sides, I'm going to get x is equal to plus or minus the square root of negative 9. That will become x is equal to plus or minus I square root of 9, which then becomes x is equal to plus or minus 3I. As we work through simplifying those imaginary numbers. Number 2, we're going to first subtract the 2 from both sides, then divide by 3. So I get x squared is equal to 2/3. X is equal to, sorry, that's a minus. X is equal to the plus or minus the square root of negative 2 over 3. So when you look at this, then x is equal to plus or minus I square root of 2 over square root of 3. Rationalize that denominator by multiplying by root 3. And your answer is plus or minus I square root of 6 over 3. Handle that exactly as we had handled those in the previous chapter or in the previous sections. Okay, so a summary of complex numbers. By definition, I equals the square root of negative 1. I squared equals negative 1. A complex number has the form a plus bi, where a and b are real numbers. The complex number a plus 0i is a. If b is a positive real number, then the square root of negative b is I root b. 5. The numbers a plus bi and a minus bi are conjugates. They're called complex conjugates. The product is the real number a squared plus b squared. Add and subtract. To add, subtract, multiply, and divide complex numbers as if they were algebraic expressions with I being the variable, and replace I squared with negative 1. Divide complex numbers by multiplying the numerator and denominator by the conjugate of the denominator. And in the complex number system, x squared equals k for any real number k is equivalent to x equals plus or minus the square root of k. And I believe that is the end of the notes. Please complete the homework assignment for Monday. We have the Chapter 7 test coming up on Wednesday. Have a nice weekend. I'll see you Monday.